This time, we are going to talk about percentile. What is a percentile? In our lesson, we have discussed that percentile also means probability, percentage, proportion, or the area under the normal curve. The percentile is a measure of relative standing given a set of data. Let me illustrate how percentile works. For example, in an examination, or you say doing your NCAE, the National Career Assessment Examination, you have there your percentile. Again, it's different from percentage. If you say that your percentile is 80, that will not say you passed or you failed in the exam. Instead, if you say percentile 80, then you are better than 80% of those who take the test. Another, if your percentile is 32, it means that you are better than 30% of those who took the test or the examination. A percentile doesn't tell you whether you passed or you failed the exam. It only tells you what is your standing in an examination or in anything that you are taking. Now, let us solve for the percentile under the normal curve. Let's take the first example. Here are the steps in solving for the z-score given the probability. First, we need to sketch the curve. Second, you need to express a given percentage as a probability. And third, split it by 0.5000. You can either add or subtract. Then fourth, refer to the z-table. You need to look for the area in the z-table. And number 5, you need to find the z-score. Let's have example number 6. Find the 90th percentile of the normal curve. Let me have the whiteboard with you. Now, again, we are solving or we are looking for percentile 90, or this is the 90th percentile. Step 1, we need to sketch the curve. Remember that in a normal curve, 0 is our mean. So it is the 50th percentile, or that is P50. With P90, we say that that is in the positive, a positive value. Now let us break 90 into, let us convert 90 into a decimal. So it's 0.9000. Next, step 3. Let's split 0.9000 by 0.5000. That will be 0.5000 plus 0.4000. Now, let us focus on the added one, the one that is not 0.5000. We need to look for 2 nearest values in the z-table where you can find 0.4000 as the nearest. Let's go back to our z-table. Now, as you look for 0.4000, let's look for 0.1000 here. 0.4000 is between 0.3997 and 0.4015. The z-score for 0.3997 is 1.28, while the z-score for 0.4015 is 1.29. We need to check which area is nearer to 0.4000. The one nearer is 0.3997. So it's under the z-score 1.28. So we say that the z-score of 0.4 of this one, of percentile 9,000, is 1.28. That is its z-score. Now, what if we are looking for P10? Let me first check. What if we're looking for P10? If you're looking for percentile 10, then that would mean 0.1000. It's 0.5000 minus 0.4000. If you check, they are just the same, right? The only difference is it's addition and the other is subtraction. Therefore, it would mean that we will have the same answer, 1.28. But since 0.1000 is below the mean, then our z-score will be negative. Let's go to the next example. Example number 7. Find the 85th percentile of the normal curve. If we split 0.85000, that will be 0.5000 and 0.3500. We'll look for 3500 in the normal curve. In the area, 3500 here. It's between 1.03 and 1.04, which is nearer to 0.3500. This one is nearer. So the answer is 1.04. Our z-score is 1.04 for percentile 85. Let's have example number 8. In example number 8, we are looking for the 37th percentile of the normal curve. Let's use the whiteboard. Remember, we're looking for P37 or the 37th percentile. We can write it as 0.3700. Splitting it in terms of 0.5000, this is below the mean, so we subtract. If we subtract 1,300, the answer is 0.3700. Let's look for the nearest areas of 0.1300 in the normal curve. If you check your normal curve or the areas, your table of z, let's look for 1300. Here, it's between 0.33 and 0.34. That's 0.1300. It's nearer to 1293, and that is under the z-score of 0.33. So here's our answer. Thus, the z-score 0.33 is the 37th percentile. But there is an error in that one because this is a negative value, so the z-score must be negative. Now the next one. Let's go to example number 9. Find the upper fifth of the normal curve. If you say upper fifth of the normal curve, it's equivalent to the 95th percentile. So to split it, we have 0.5000 plus 0.4500. If you look in your z table for 0.4500 here, it's nearer to this too. If you're checking which one is nearer, both have the same distance. So let's look for the exact value. The first one is having a z-score of 1.64, while the other one has a z-score of 1.65. Now, what is between z-score of 1.64 and 1.65? One way is to do averaging, but another is to do it logically. Let's have 1.645. So the z-score for P95 is 1.645. Let's have the last problem. Problem number 10. We first need problem number 10. In problem number 10, it says, the results of a nationwide aptitude test in mathematics are normally distributed with a mean of 80 and a standard deviation of 15. The question is, what is the percentile rank of a score of 84? First is, we need to solve for the z-score. Remember in lesson 2.3, z-score is computed as x minus x bar over s. Given x bar and s, this means that the data is within a sample. Let us substitute. X, or the score, is 84, minus our mean is 80 all over 15. So we have 4 over 15. 4 over 15 is 0.27. This is now our z-score. Let's sketch the curve. This is 0. Let's imagine this is 0.27. If you say percentile, it's always to the left. Why? Because you say you are better than the percentage of these takers. So we'll always go to the left. Remember, it passes by 0. And 0 to a negative number is 0.5000. While 0 to 0.27 is 0.1064. Let's look for this area. We simply add them. So the probability of z, which is greater or less than 84, not z, x, x less than 84, the answer is 0.6064, or we say that 60.64%. In percentile, we drop the decimal point. So we say this is P60 or percentile 60. Thus, the percentile rank of a score of 84 is P60, or the 60th percentile.